What's up YouTube? Dougie Chong here. Today I have a really cool video to show you. It's a restoration project of a robot I made in second year university. I'm really excited to show this project because it hasn't been operational for a number of years because power supply for 12 volt and 5 volt DC used to sit here. But then I just found two power adapters from AC 5 volt and 12 volt with enough amps, and then I married them together to the power cables and it works. The only other thing I had to do to restore this was I had to short these two cables to make the real-time clock chip work, otherwise the code hung up. So the premise of this robot was to sort white and orange ping pong balls into different patterns into these boxes here. There were a lot of constraints such as size, cost, and it was judged based on efficiency, and it needed things like an on-off power emergency kill switch. Well, yeah, I'll just show you how it works first. So before I show you the operation, I'll tell you a little bit about how it works and what the design was. The design was to use gravity to do most of the work, so it starts top down, the balls flow down. There's a motor in here that'll go exactly to get a ball, exactly to get the other ball, 60 degrees each, and then it uses gravity. It'll take the ball, it'll fall down into this tin here. Now this tin is where the real design is. It goes to one of 6 slots here. It'll hit, the ball will hit this plate and roll exactly into the slot based on where this plate is positioned. And then it'll fall directly into the box, into one of these 6 squares. The design is very fast and very efficient. Once the box is filled, this DC motor will spin this plate, and then the lid of the box will fall down from this coat hanger and get closed under this wheel. So we found unipolar motors were good for these precision movements, but for the power to close under this wheel, we needed a strong DC motor. Alright, let's see it in action. We'll turn it on. Turn it on. So you'll see a message show up. There's also instructions there. And an arrow that tells you which way this disc will rotate. Alright, so we'll go ahead, we'll hit 1 for a new operation. Reset balls. Okay, so it says to load the balls now. Take the balls. This funnel design was also uniquely made so that the balls wouldn't get stuck when they get dumped in. They don't get stuck, they come down here, they're ready to be loaded. So, then I just slide this here box and get ready to be loaded. So there's some of the circuits that control the unipolar motors. Here's the brains of the board. It's all programmed on a PIC F877, programmed in assembly language. Back in its day, it could connect to a computer through an RS-232 port, and it could tell the time with an RTC chip. Alright, time to load some white balls in. Same idea. Alright. Get the second box ready. So I'll just show the two simplest patterns. It was all white, I think, is pattern 1. And all orange is pattern 2. So it's supposed to count the number of balls. So this is 4 white, 6 orange. I think I did actually put 4 white and 6 orange. So that's a good counter. Uses these mechanical switches here as it goes by. Infrared was the much better design, but this is what we ended up with. It's important to note that our design only uses 3 motors. There's one unipolar that takes either orange or white. There's one in this tin here that selects one of the 6 slots, and then there's one that turns this disc to close the boxes. Alright, so now we'll just push start to continue. Say there's 2 boxes. Do pattern 1, which is white balls. Pattern 2, which is orange balls. And I'll start it. You'll see it takes a white ball, dumps it, keeps on putting them. So I'll show what goes on in the tin later. So yeah, then it rotates. So now it's going to orange balls. You can see here it's loading up that box, and it rotates. The final rotation is a little finicky, but there it is. Done. So when it's done, it shows a done message. Push star. Tells you the time. I think that's accurate. January 2nd. Yeah. And then you can see patterns. Tells you you selected pattern 1 and pattern 2. It'll tell you the balls that are left. And it can tell you the date ended. Time it took, 22 seconds, so that was pretty good. We ran this in a competition. Only one group could get maybe 20 seconds. There was a way to do parallel processing to make it faster. Our robot did end up winning the competition. Then you can do a new operation just straight from here. Maybe I'll show some other patterns. Here, we'll see if the sensors work. Again, we'll load 6 white balls and 6 orange balls. There's the white ones. And the box in. Orange ones. So I missed one orange on the sensor, but close enough. Alright, we'll say 2 boxes. Say patterns 3 and 4 this time. Not entirely sure which patterns those are, but we'll see. Got a little stuck there. Different view. Always get stuck there a little. But for being like 3 or 4 years old, it's not bad at all. So that's my robot. Hope you guys enjoyed.